In today's video, we're going to be covering cross-validation within Python with the help of Scikit-Learn. So first off, what is cross-validation? Well, cross-validation allows you to split up your data set into different subsets or also folds. And when you run your model through it, you're going to be able to get multiple scores at the very end. Now, why this is important? Essentially, in machine learning, we've talked about train, test, split, and how you can split up your data between a training set and then also a testing set. Well, at the very end of train, test, split, and once we run our model, we're going to only get one score. And the problem is with only getting one score is it can sometimes be biased. And I'm going to be showing you an example within this video. Some other benefits of using cross-validation is it can help you select certain features, a specific model to run, and also help with parameter tuning. As a bonus in this video, I'm also going to be showing you Stratified K-Fold. I'm also going to be talking about how you can call K-Fold before running your cross-val score. And then at the very end, we're going to do an example with a pipeline. So we're going to take this from like a very beginner entry level version of cross-validation all the way towards an intermediate. Hope you guys will enjoy this video and let's start coding. Okay, so let's start off with importing a few different libraries. We're going to import pandas as PD, shift enter. This runs a cell and then builds out a brand new line. So see me this do a lot. Let's import numpy as np, shift and enter as well. Next, I'm going to randomize some data so that way I don't have to create brand new data for this cross-validation. So I'm going to show you how to do that real quick. No worries if you don't understand how this code works because you can do your cross-validation without it, but just copy it so that you have the same data I do. So we're just doing a random seed over here. And then what I'm going to take a look at, say fastball speed equals np.random.rand int. I'm going to randomize the ints between 90 and 106. And then we're going to say the size is 500. Okay. And then I'm going to look at Tommy John, which is a surgery that pitchers get if their arms wear out. And then I'm just going to put over here, fastball speed is greater than 96. Because pitchers that threw faster, they tend to get more Tommy John surgeries. So I'm going to say this is np.randomChoice. Between 0 and 1, right? You get a surgery or you do not get a surgery. Then I'm going to say size equals 500, just like above. And then we're going to put our probabilities in here. So I'll just put that between 0.3 and then 0.7. Essentially, I'm taking a look at pitchers that throw over 96. They're more likely to get Tommy John surgery. And that's what I want this data to show. And then not 0. So now we have all of that built out over here. Now we can start assigning this to a data frame. So I'm just going to say D equals over here. I'm going to say fastball speed. Said, feel free to skip ahead and just copy this code. But this is just me adding in some data over here rather than a CSV. That way you guys can just put this in pretty easily. Speed. And then we're going to throw in Tommy John. This, again, that is the surgery name. And we have that. And then one last step, we're going to say df equals pd.data frame. And I'll just put D in here, or data equals D. And then df, boom, there we go. Okay. So you can see 500 rows, 2 columns, we have a fastball speed, and then we have pitcher has Tommy John over here. So if you guys copy exactly what I have with the seed and also the code here, you should have the same exact data frame that I do. So with that in mind, let's start coding. So I'm just going to go over here and we're going to set up our X and Y. So the first thing that we're going to do, we'll just say X equals DF, and we'll throw in here fastball speed, right? That's over here. And then our Y is going to be if someone gets Tommy John surgery or not. So we're going to say DF this Tommy John. Okay. And the first thing we're going to do, and we're going to show you an example with this first, is just do our normal train test split in the beginning. So I'm just going to put here normal train test split. And if you've been watching the series, you're super familiar with it. If not, we're splitting our data in essence for a training set and then also a testing set. So you have to write out this fun code: x train, x test, y train, and also y test equals train test split x and also y, our test size. So it tells you how much is going to be in our test data set. And we're going to say 0.2, which is 20%. And we'll do random state of 11. Now, before I run this, I did forget one thing. So I'm just going to go above over here and I'm going to import in train test split, which is from Scikit-Learn model selection. So from Scikit-Learn.model selection, import train test split. So that's run, right? And then we should be able to have this go. See is line 11. And now we split up our data, right? So, okay, we're looking pretty good now. And for this one over here, we have a binary output, right? 0, 1 if someone gets Tommy John surgery. I'm just gonna do something basic and do a logistic regression. If you're familiar with those, right? You have either a result that's a 0 or a 1. And then you also have your horizontal axis, which is pretty good, right? Because you have fastball speed over here. And how I coded this out is pitchers that throw faster are more likely to get Tommy John, which is true, but just wanted to throw that in here again. So pretty easy, right? I'm just going to LR equals logistic regression. Have that over here. And also, because I'm dumb, I did not import this. So make sure that you import this also from sklearn.linear model import logistic regression like this, right? Now you can call this, make sure it works over here. And we have our logistic regression. Now we're going to fit our data. So we're going to say lr.fit. We're going to throw in here x train. And then we're going to throw in here y train. And then we're going to do just .values .ravel. Make sure you put this, otherwise it will not work properly. We have our logistic regression over here. And you can just see our normal score, right? So lr.score, x test, and also our y test. Okay. And our score is 0.71. So the reason why I wanted to show you this in the beginning is train test split and running your score over here isn't always the most accurate, right? So our first example is 0.71. We have our test size 0.2, and we chose a random state 11. Well, if we choose a different random state, this score over here could be higher or it could be lower, right? It just depends how the data is split up and when the model is run, like, is it going to get accurate results or not? So let's do another example of it, right? So let's test this again. So I'm going to just go over here and use X train again, but this time we're going to name this number 2, right? So what I'm going to say is X2 train, X2 test, Y2 train, Y2 test. We're going to still keep 0.2, but this time we're going to do a random state of 25, right? So let's shift and enter. Again, I'm going to do the same thing over here. We're going to keep this logistic regression the same, but this time we're going to put X2 train and Y2 train values over here. So we have our logistic regression. And now let's do our LR score. So over here, right, we fitted our data, and then we put X2 test and Y2 test. And take a look, we have 0.8. That's a big difference between the two, right? That's only from changing this random state over here. We have 0.71 when it's 11, and then we have 0.8 when it's 25. So let's take a look at like a basic cross-validation score, essentially, and how that would specifically work. So like above, let's say basic cross-val over here. And we'll do a little bit more advanced stuff in a minute, but we'll start off, right? So make sure you import this. So from sklearn.model selection import cross-val score, just like that. Okay, next thing I'm going to do is call this out. So I'm going to say CVS, well, CV score, but CVS over here. And I'm going to say cross val score. And then the first thing you have to do is put your specific model. Now, I already called our logistic regression above LR, so I'm just going to put this over here. You can literally put this code, logistic regression, in it. But again, I'm just going to throw LR. Next thing I'm going to do is our X and Y values. So we're going to put X over here. We're going to put Y values dot ravel, right? And then we're going to put a CV of 10. And CV of 10 is probably the most common that you're going to see. So we're going to get 10 results out of this one. So again, CVS score, cross val LR, X and our Y value, and we'll ravel this over here in our CV10, shift and enter. And now just to show you all the different scores, right? We have 0.68, 0.78, 0.72, 72, 78, 82, 74, 74, 76, and also 0.82. So they're all over the place, right? And there's two things that you should take a look at with this, at least as like a very elementary level. First thing that we want to do is see our average on this. So we can just put np.average and throw in our score over here. And what this is going to do is just average these out. And again, we have 0.756, which is kind of funny, right? We had 0.71 and then 0.8, which is kind of in the middle between those two scores. But just to show you like how big of a range this is over here between just running it twice with two different random states. Okay. Next thing we want to do is a standard deviation. So we can just do np.std, and then we'll throw in our CV score over here instead this time. And we have a standard deviation of 0.04. So like if you think about it, we add 0.04 here, we're at 0.79, and really it's almost 0.78 or 0.8 just because of what's over here. And then if we subtract it also, we're pretty close to 0.71. And yeah, it did take me a little bit of time to make sure we got a 0.71 and a 0.8 over here. Did that on purpose. But just to show you, like, our cross-val score gives us a lot more accurate results. And we can change this over here, this value of 10. So we can change it 5, 15, 20, and I'll show you some other examples over there. But essentially pretty powerful. Now, I want to show you an example where we define our K-fold beforehand. And usually you'll see this in other examples. So I'm just going to say define standard K-fold. And we're going to have to import this in again, right? So from sklearn.model selection import K, capital K, by the way, import K-fold. And I do have an issue. So what did I put over here? Needs to be a capital F as well. And now we have that in. Okay, now let's call our K-fold. So I'm just going to call it KF, right? K with the capital F fold. And now we can talk about how many splits that we want to have. So in this instance, let's do 15 splits. We did 10 above, right? So let's do 15 this time. So n splits equals 15. There's another option where you can shuffle your data. I'm going to say that's equal to true. And then lastly, our random states. So we can pretty much replicate this result again. I think earlier, what did I use? 42. So I'm going to use 42 again down over here. And then we should have our K-fold that is now called. Okay. And just to do our scoring system over here. So I'm just going to put KF score equals, and then cross val score. Now again, right, our logistic regression, which is LR. Then X can do Y dot values dot ravel. And then we're going to say our cross validation CV equals KF, which we defined above over here. So again, just more data on this side of things. You could be lazy and just put over here like what I did. Where is that at? 10, right? But in this instance, we already defined this above, and we're just going to throw this over here. Now there is a little bit more that you can do to this. You can actually define what scoring method you would like to use. Here we go. Just take a look at the Scikit-Learn documentation. There's a ton of great resources on the website as well. But you can see all the different scoring metrics. So you have accuracy, balanced accuracy, top K, F1 micro macro. You have clustering, you have regression. So again, feel free how you want, right? You can see over here how you essentially do it. So essentially you have a bunch of different ways that you could add in scoring. So I just want to show you that does impact it. So the first example over here, I'm just going to say F1. So scoring equals F1, and that should be lowercase f1. We'll run that. And then I'm just going to do KF score 2, and we're going to throw in accuracy, right? Accuracy. Feel free to read up on all the different scoring types and determine what methods you would like to use, and feel free to tweak your models. But for this way, I'm going to do that. So first thing I'm going to do is just show you what these look like. So we're going to start with KF score, right? So we have our array over here, and already this looks a lot less accurate than what I used above, but that's okay. So now we can go over here and say np.average, throw in our KF score. 0.68, which is a lot worse, right? And then let's take a look at the standard deviation, right? STD, and 0.05. So that definitely did not work with this F1 score. And just to show you what number 2 looks like, oops, I accidentally removed that. Or we'll throw it down below, right? Another array. So we go all the way down to 0.63, it looks like, which is pretty large, right? And then 0.85 over here. Might have a higher average, bigger standard deviation, but we will find out shortly, right? So throw this in over here, K score 0.75, which is a big difference with our accuracy score. And then STD, and then 0.06, so a larger standard deviation, right? I'll show you a stratified K-fold, which is a little bit different. This time you're taking a look at percentages for the different samples in each class. So let's throw that in here, the stratified K-fold. And again, we're gonna have to import this in. So from sklearn.model selection, import stratified K-fold, right? And that is in here now. I'm just gonna build out a few more cells. Okay. So first thing I'm going to do is KF3, because we already have KF1 and 2 essentially. So we're going to say KF3 equals stratified K-fold. We'll say our splits this time is n splits equals 10. Well, again, shuffle equals true. Do like that. Shuffle equals true. And then random state we'll say is, I don't know, what, 11. So we'll throw that in here. And then we'll say KF score 3 equals, and then we'll throw in cross val score or logistic regression x y values dot ravel, and then CV equals KF3. And I don't care about the scoring this time, right? And why do I have an issue? And because I put y here twice. Okay, so now that is implemented. So now if we want to see our KF score 3, right? There's our array once again. And then we can just do our np.average and our np.std. np.std, and throw this in here. So this time we're taking a look at 0.756, and our standard deviation on this one is 0.03, which is a little bit lower than I think everything else we've had so far, which is pretty nice. And I also wanted to show you guys a pipeline example because the previous video was on pipelines, what I upload on the channel and also on the series too. So we'll just say pipeline example. So we're going to build out our pipeline. Now I do want to throw in an additional step in our pipeline. So we're just going to do like a standard scaler. So pretty easy stuff. And I do have a video on standard scaler. That is a part of pre-processing. Import standard scaler. And I'll put in the description too if you want to learn a little bit more about it. It's not too important for this video in itself, but we're going to throw this into our pipeline. So we're going to say scaler equals standard scalar. Just copy and paste right here. Right, we call our, not scales, scalar. Okay. Now let's import our pipeline. So I like using make pipeline because it's easier, at least in my opinion, and you don't make as many typos. So pipeline imports make pipeline, and I do make a lot of errors. So that's why I like make pipeline instead. All right, so now we're gonna say pipe one equals make pipeline. Now the first thing we want to throw in here is our scalar, right? So we just have our scalar, and then we're going to run a logistic regression right after. Again, super, super basic pipeline, full video in the description about pipelines and go much more in depth. But I mean, I talked about that in well over 30 minutes in that video. So essentially we're calling our pipeline, which first scales our data, and then it's going to throw it into a logistic regression, right? But one of the benefits of pipelines is you can also use cross-validation with it. So, okay, we have our pipe one over here. Now we're going to fit our data. So we're going to say pipe one dot fit. We'll throw our X train in here, then Y train dot values dot ravel. Throw that in here too, right? So again, basic pipeline, our standard scalar, and logistic regression. Okay, and now we can actually take a look at our scores. So let's just say our scores this time, scores pipe equals cross val score. Then throw our pipe in here, right? Because we're going to be using our pipeline this time instead of our just basic logistic regression, which is pretty nice, right? X, Y dot values dot ravel. Throw that in here. And then CV equals 10. Okay. Now we have that in here. And if we want to see our scores, again, just throw scores pipe. You can see our array that's been built out. And then I'll just do np.average, and then np.std, np.std. Throw the scores pipe into both of these, and let's see our final results. And we'll do an overview again, right? 0.756 and 0.42. Okay, so let's just talk about what happened overall, right? And the reason why we're using cross-validation. So first we have our data over here that we imported. Again, this does not matter too much. It's just how I built out this data frame. But when we use train test split over here, the random state is going to give you different data samples each time for your train and test sets. So in this first example, when I used random state 11, we had a final score of 0.71. When I did a random state of 25, we have 0.8. So it's not the best method overall to use to essentially see how accurate your model can be. So by using a cross-validation score, we're going to get multiple scores over here, right? In this example, we get an array of 0.68, 0.78, 0.72, all the way through 0.82, which we have over here twice. Then what's the most common thing to do is take a look at the average and also the standard deviation on it. So we can see our NP average is 0.756 and then 0.0427 for this first instance. Another thing you can do if you want to add even more additional information to it is import a K-fold before you do cross-evaluation score, right? And then we just have our CV equal to KF, which we define above, which we can put on our splits, our shuffle, and then also a random state. So that way you can duplicate the exact same results. Another really nice thing with cross-val score is how many different options for scoring. And you can take a look at the Scikit documentation to see all the different types of scoring methods. I just threw 2 ones in here pretty quick, F1 and also accuracy. And again, you can build out your array, again, average, and also your standard deviation. You also have a stratified K-fold, which you can use. It's pretty popular. And lastly, you can apply this to your pipelines, which I highly recommend. So just build out your pipeline over here, fit your pipeline, and then take a look at your cross-val score. And then when you run your cross-val score, in this instance, you don't have to put in your model. You just put your pipeline in over here, and then you can do your CV and get your same exact results that you were expecting. Hey, if you made it this far, you watched this entire video, I really appreciate it. You're one step closer to learning even more information about machine learning. Well, these videos do take a while to make. If you want to help support the channel, you could subscribe. It's absolutely for free and does help grow the channel too. Now, I do have a bunch of other videos on machine learning, so make sure to check out this playlist right over here.